Alright, I'm Sam, and yeah, look into my world of trifolds. So I'm going down a whole list about things that have to do with chemical bonding. So, I should get off this little island before it collapses. Alright. And let's go down this line. Alright, hi there. So this is my enclosed box made out of cardboard and Sharpie. Pretty nice. In here I can deposit cool facts, definitions, and also just explain things. So let's take a look at the first thing I need to mention. What's a valence electron? Watch the definition. Either way. A valence electron is an electron of an atom located in the outermost shell, also known as the valence shell of an atom. It can be transferred to or shared with another atom depending on the type of bonding you're doing, either ionic or covalent. Specifically, you can only share with that. Okay, now let's look at another question I was asked. How are valence electrons a part of ionic and covalent bonding? Now, this is kind of a dumb question. Oh, valence electrons allow atoms to be stable. In this case, if you look at an electron dot diagram, those dots are valence electrons. If you look around at the composition of CH4, it has the central carbon atom with the 4 valence electrons. 1, 2, 3, 4. In order to get 8 to be stable, we need to add 4 more electrons. That's why we put 4 hydrogen atoms in there, because a hydrogen atom has 1 valence electron. So if we put that in there, one here, one here, one here, one here, it'll make it magically work. And that means it'll be a stable, easy, nice bond. Now, here's another little feature about covalent bonds. You can move the atoms anywhere. That's right, anywhere. So, the third question I got asked to say is, what is an electron dot diagram? I mean, I've been showing you these, but what do they mean? Well, an electron dot diagram is what you will see later on, and it shows us the valence electrons of an atom. And it makes the process of making ionic and covalent bonds easier in a visual way. If you look at the example shown before, the letter is the letter C. That is a carbon atom, C. And that is the chemical symbol of the carbon element. Now, if you look around it, there are 4 dots. One on the top, one on the left, one on the right, one on the bottom. Those are the valence electrons. Let's take a look at how electron dot diagrams can vary across the periodic table. If you look at the element hydrogen, it has 1 dot. That's because it's on the furthest side of the periodic table. That makes it easier to know that column 1 of the periodic table all have 1 valence electron. That's a nice little perk to know. And this, I don't know, this will be repetitive across going to the right of the periodic table. So, that is because it's on the further side. Now in column or group 2, all the elements would have 2 valence electrons. Makes sense because, you know, it's on group 2 and group 1, you know. Now this is where it gets a little bit weird. We're going to skip through groups 3 through 12 and get to group 13, where there are 3 valence electrons. Now this is where, as you get a higher number or further to the right, the higher valence electron count around an electron diagram is. Next question. What is a chemical bond? A chemical bond is a lasting attraction between atoms, ions, or molecules that enables the formation of chemical compounds. Alright, now what is ionic bonding? Ionic bonding is a type of chemical bond that involves the electrostatic attraction between what? I got this off of Wikipedia, so yeah. Okay, let's start this over. Ionic bonding is a type of chemical bond that involves the electrostatic attraction between oppositely charged ions. It is the primary interaction occurring in non-light ionic compounds. Okay, let me explain how ionic bonding happens and how names of the compounds are produced. Quick note: why am I wearing sunglasses? It's because my really bright production light really hurts, and it's really bright. Oh, my eyes. Ionic names are created by the number of atoms in a chemical formula. Let's say you have FeCN in parentheses 3. It would be iron cyanide. Because there are either one or two of the same element. Typically, ionic bonds just all have the name ide, but in this case, absolutely not. I don't really understand. Ionic bonding happens when an atom gives or takes valence electrons. There's absolutely no sharing of these electrons. Yeah, there's no sharing of these electrons. It is basically when one atom takes valence electrons from the another element or atom to gain 8 to become a stable element. Atom. Shadow. Quick tip, don't get a shadow on your green screen. It's like really bad. That's why I can't kick my legs. Okay, what is covalent bonding? I need to get this over with because my eyes are burning. It is when two or more atoms share electrons. These shared electrons are known as shared pairs or bonding pairs. Now let me explain how this happens and how they are named. Covalent bonds happen when one or more elements combine together to make one atom stable, such as H2 or dihydrogen, or dihydride, which is a covalent bond. Covalent bonds are tricky with the names. Covalent bonds have prefixes. When there's H2O, that means it is dihydrogen monoxide. There's a di, which is 2, which dies 2. That is there because there are 2 hydrogens. Monoxide, well, mono is only used on oxygen. So you can't have monohydride. Now what is a polar bond? A polar bond is a covalent bond where 2 atoms have unequally shared electrons between each other. A good example of this is water, or H2O. Now, what is a nonpolar bond? Well, a nonpolar bond is a covalent bond where 2 atoms share a pair of electrons between each other. A good example of this is dihydrogen, as mentioned earlier in the video. Let's look at 8 different electron dot diagrams for ionic compounds. Na2SO4, Fe, parentheses NO3, parentheses 4, AlCl3, Ni4, parentheses NH4, parentheses 3, PO4, AgC2H3O2, and H3O. So I know I missed an entire other question. That's probably really important, but I want to get this done because I'm burning in here. Yeah, I know. I'm in my I'm in my bedroom, so it's very hot. There it is. There's the light. So, yeah, give me a good grade because I really deserve it. Oh, dude, that was unsafe.